Thank you. I'm very happy to be here today. I'm a little bit sorry that I can't stay. I have to leave pretty soon after my presentation to go to the 3D printing show in Paris. But it was really great to see this morning already with all the inspiration and what people are doing in the maker movement and in the maker space, how people are innovating and thinking about new ways of either creating things or sometimes doing business. So what I want to talk today about is a little bit about the open platform that we're building. But before I go there, I just wanted to let you know that if the clicker works, which it doesn't, let's see, it does. So I got introduced to 3D printing a long time ago. This is going to date me crazily. But about probably 20 years ago, I was a designer for automotive. I was designing interior parts for Audi, and we had to get our prototypes to Audi like instantaneously. They had to work because there was a mechanical system in it, and I used 3D printing to get my prototypes done. I was working with this spin-off in Belgium called Materialize. It was a spin-off from the University of Leuven. In the meantime, Materialize has been grown to become one of the biggest service providers in the 3D printing industry. They really have built up an amazing know-how. And it's interesting, at the time, I thought, wow, this technology is just going to take off like there's no tomorrow. In 5 years, everybody's going to be 3D printing. No, didn't happen. I wonder why, right? But a couple of years ago, let's say like 5 to 10 years ago, this actually started to become true. And now, last September, I was at the 3D print show in London, and I saw this really nice gentleman from Roland. Roland just brought out their own 3D printer. And I told him, I said, I'm from Autodesk. And he goes, wow, Autodesk, I know Autodesk. And he walks over to the desk with all the little gadgets that they had, and he picks up this little figurine. He shows it, and he's very proud. And he says, this is what my 6-year-old made with 1-2-3D Creature from Autodesk. And I'm like, wow, that's just, now I'm happy and proud that I can be part of that, right? We have been working on allowing people to basically imagine, design, and create a better world. That's our vision, really, for the company. And in the last 4 or 5 years, we've been really focusing, on the one hand, of course, we have our professional solutions. On the other hand, we have consumer solutions that are free for use. And the whole purpose there is that people can be creative. And, I mean, everybody's creative, there's no doubt about that. But the question is, do you have the tools to bring out that creativity in you? That's what the question really is. And we've been trying to figure out how we can do that. Because ultimately, we're just giving the tools, and the people use their creativity to do something fun with it. So we've been really focusing on that for a while. But of course, we also have our professional customers, and they make the most amazing things, whether it's the tallest building or really very cool cars, or they're doing things like games. We have a lot of gaming technology in our company, or even movies. This is something that a lot of people do not know about Autodesk. Most people know us from AutoCAD. But we actually have very strong, powerful tools for doing special effects in movies, and most of the special effects in the movies today are being done with our software tools. So that's really, really cool. So we basically have a very broad range of people using our tools to explore their creativity, to imagine, design, and create that better world. Now, as I said, we've been working on consumer, but we've also been experimenting. We're very much an experimental company in the sense that we have a research lab where we do all kinds of crazy things, whether it's biotechnology or it's something else, we're really like diving into what the possibilities of the future are. We also have what you could call a fab lab, but I would say it's a professional workshop, where you have 3D printers, laser cutters, CNC machines, a wood workshop, a metal workshop, an electronics lab, a sewing lab, you know, a professional kitchen. You may wonder why we would have that. It's because we have a huge maker community in our organization. It's called Instructables.com. And Instructables.com, what they do is they basically put instructions online, and it's for the maker community, so that a maker can actually share what they have created and share it with the world, and other people can do it too, or can even extend and better it. So we have been experimenting with all kinds of stuff in that space. And 3D printing has been one key experiment for us on all areas and in all levels. And we've seen amazing things happen. We've seen kids who built their own glasses because they really hated these lame glasses that they got. And actually this guy, he's now 14 years old. He started doing 3D printing when he was 10 because he went to TEDx in Belgium. And he saw a 3D printer. And he was all enthusiastic about it. And he figured, you know, I can go and do something with that. So he used the tool that we bring out, which is called Tinkercad. It's a free tool. So he tinkered, and he built his own glasses. And by now, 4 years later, he is building this business where he is going to sell custom-made glasses so that he can fund this really interesting initiative to get glasses to underserved areas of Africa where kids cannot get glasses because they're too expensive. And his whole idea is that I can put a printer in Africa and have the kids print their own glasses. And, you know, it's really cool, those types of things that you see happening. And this is all maker movement, right? So let's talk about 3D printing then. We've explored this thing. It's clear that there's a huge opportunity in 3D printing. Everybody is in complete agreement, right? It's a growth area for the amount of money that you can make there. The hardware business is going through the roof. Clearly, some areas like aerospace and medical industry are benefiting tremendously from this technology today, could benefit a lot more in the future. And then the maker area is also growing like there's no tomorrow, and 3D printing is a tool that helps you do that. So the reality, though, of 3D printing is a little bit different. It's not that straightforward to go from a 3D model to a successfully printed model, right? We see, and we've been talking with a lot of people, failure rates up to 75%. Now, that's not interesting if you want to build a business out of 3D printing, or if you really want to get to a very good result very quickly. So we figured, you know, this is not a good situation. Why is this happening? Well, first of all, let's look at the process. What happens is somebody looks for a file, or they make their own file. They use a CAD tool. They create a really nice design. They say, yes, I'm ready to go. Oh, wait a second. I need to go and 3D print this thing. Okay, that means that I probably need to take it to 2 to 5 different products to make it print ready, and check off that there's no holes in the mesh, and, you know, it can be printed. I have the right support structure, whatnot. Then they say, okay, now I have my printable file. I'm just going to choose a print solution, whether it's an FDM solution, an SLS, an SLA. There's solutions plenty, right? Depending on what you have access to. They decide on a solution, and the next thing that happens, the thing fails. So now I spend all this time, I spent all this money, and, I mean, no result. So what we said is, okay, why is there no result? What's the problem with the broken workflow? Can we go and solve this with a piece of software? And we decided we can't. Because the only way to really solve it is by looking at all the different elements. You have to look at the hardware, the software, and the material science, bring all these elements together in order for it to be really a successful story. If you can define a material at the digital level, that is great. But if you cannot communicate that material information to a printer that understands what that means and can do something interesting with it, it really falls apart. And if you have a piece of software that doesn't understand those different aspects either, it falls apart too. So our thinking is, yes, you can innovate on the hardware side, but the process is still broken. You can innovate on the software side, same thing, and the same thing for materials. So we decided we're going to do something about that. We felt we were good and well positioned to help with that solution. Because ultimately, yes, the opportunity is huge with 3D printing, but nobody has cracked the code to successfully 3D print, you know, at the normal level. I'm not talking about very highly specialized people who know how to tinker with certain different tools and all of that, right? So we felt we needed to build something. So we decided we're going to build an open platform that people can collaborate on. people that come out of the hardware business, that come out of the material science business, that do software development for specific things, that do things like service providers, right? They also have their needs. They also know this industry and know how to solve problems. And we work together on the other side with professional engineers, professional designers, but makers and consumers just as well, to start figuring out how are we going to solve this puzzle. So the Spark platform, we thought about it a little more, and we wanted to really experiment on the hardware. And that's really hard if you don't own any hardware. So we decided we need to have a reference implementation of our software. So we decided we're going to build a printer just as well. So we'll print a reference implementation that is going to be, it's called the Ember printer. It's an SLA printer, and it's really focused on a very small area of the industry. It's not really intended to become a hardware company here. It's really intended as a reference implementation, very similarly to what Google does with their Nexus, where they prove what their Android capabilities are using that hardware piece, right? We're doing the same thing. So that's how we feel we can accelerate on this, because we now have a hardware side to the business that we can test our software with. But, of course, we want to make this all open. So this is the hardware. I can't promise you that this is exactly what it will look like, but it will be something along those lines. And the idea is that we make this open. So if you think about the RepRap, what happened with RepRap, it was all available to anybody. Anybody could start building an FDM printer. The end result is there's tons of FDM printers. The technology has evolved tremendously. The stuff that's possible now couldn't have even been come up with a couple of years before, right? We think that maybe that's something that we could help with too on the SLA front. So this is an SLA printer that we will also make open and available for you to just take and make your own. Now, can we make everything open? Probably not, because not all the technology is owned by us. But whatever we can, we will make open and available for people to start using. So the concept then. What is the concept of Spark? It's really intended, so Spark, the platform, is intended to drive open innovation in the community. And the way we want to do that is by building blocks, APIs, SDKs, that people can readily use to start innovating in this industry. And any kind of people that have anything to do with 3D printing can use it. And you've seen a couple of early adopters. It's funny because we saw these same names this morning. And we have been working with Dremel, which is Bosch's tool in the United States mostly. They're bringing out a 3D printer. They're working with us on the platform. And we're also working with Local Motors. What I want to show here is that we're really looking for partners that can span the gamut, going from consumer all the way into industrial. And because that's the way we will innovate. We can't just focus on one area because it won't really get the right result. So we really want to have the breadth that is needed. Because if you think about it, in the consumer space, 3D printing is overhyped, quite frankly. Everybody talks about it, and I mean, yes, it's very cool. You can do crazy stuff with it. But if you look at what is being done today, most of it is gadgetry. It's not very useful, right? Whereas on the industrial side, it's totally underutilized. I mean, I was doing this prototyping 20 years ago, but there's so much more than you can do with 3D printing that has not come to fruition today. And it's because of all these barriers. So if you think about, let's say you're a designer, right? You want to design a bicycle. You want to make it as light as it can be, but it needs to have a certain strength. Today, if you want to do that and you use the standard tools for that, you're going to end up probably with an aluminum frame that is really cool. And that will maybe be strong enough. What 3D printing can bring to the table is it can remove some of the barriers that you have today, because it can actually remove a barrier of your skill set. Maybe we can do something with the software that makes it much easier for you to to create your design intent, right? But it also can change something around the cost and the performance. So in this case of the bike, what if you could create a lattice structure that could make the bike extremely strong, right? But it would be an intricate structure that could only be created with 3D printing. This type of stuff is possible with 3D printing because at the end of the day, it doesn't matter if you're making a little square block that is as simple as you could do, or you make something like that. At the end of the day, the printer is going to go, and it comes up with this product, right? The complexity comes for free. So what if you could do that kind of thing? That would be pretty cool, huh? Now, think about a design of a chair. Maybe I want to design a chair, and I have some parameters around that. It needs to have a certain weight, right? It can hold a certain person, and it has to have certain size because it has to fit in my room or whatever it may be. What if the computer could come up with some ideas around that? And it wouldn't have to be limited by a subtractive manufacturing process. Because a lot of the times, as a designer myself, what I found was I came out of the university and had all these great ideas, and the world, it was filled with possibilities, until I started working at a company. And all of a sudden, I had customers. And those customers had requirements. And it wasn't about, it wasn't about whether or not this was a cool design. It was about how much is it going to cost, how much is it going to weigh, da, 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 da. And at the end of the day, I felt so limited, right? So the idea of tools is about, can we open up your creativity? Can we allow you to be unlimited in your thinking? And 3D printing has that potential, and the software tools can help with that. Because look at this. Maybe you end up with this result. Your original design was very cool, but it was like 10 kilos. That's probably not what you want to achieve. Your secondary design, still the same shape, already 4 kilos. But if you can completely go crazy, you could go with the third design, and now you're looking at not even 3 kilos. But of course, that thing could never be made with a CNC machine. But it can be made with a 3D printer. So those are the types of possibilities that 3D printing holds. Let's take it a little bit further. Airbus. They're doing crazy stuff with their research. They've been investigating what is possible. What do people want when they fly? How many flying is going to happen in the future? Clearly, a lot of people feel that they want to explore the world, and it's not enough to do it over a social network behind your computer. So yes, there's a need for more planes. Question is, can we make planes that are sustainable, that can fly easily, that can have a better experience for the people who sit in it? And yes, they could, right? So if we could have really interesting material usage, right? Think about digital materials. A digital material will allow you to combine different properties. Maybe you combine flexibility with strength, right? And then if you can steer your printer to understand what that means, and you have a software solution that can build the right shapes that are relevant to this need, right? You could come up with a vision like this. You could come up and envision what the future could look like if we could really crack the code on 3D printing and make it to what it can become, and turn and innovate together on this whole new type of technology and make the tool worthy of what it, the ideas it holds. And ultimately get to this whole promise of mass customization, which is what 3D printing really has in the back. Right? This is what we've been talking about with 3D printing. You can do mass customization. You can only do that if you crack the code on some of these areas here. And hopefully, Autodesk can be a player in that, can help a community like the maker community to take this technology further, to explore your ideas better and do more things with it. So with that, I want to really thank you for your time and interest.